Okay, so I was looking at Temu.com and they have yet another ESP32-S3-DevKitC-1 clone for sale, and it was only $10, so I bought two of them, and there is absolutely no information on these things, just pictures, but I found some information on the internet. That's all there is. And I found that there was a GitHub site, excuse me, and there isn't that much information there either, and you kind of have to work things out for yourself a little bit. But there was a README file a lot of Chinese stuff in there. Seems to be saying that the GPIO 48 is attached to the LED, which is interesting because I believe that the original expressive board had it on 38, but it seems to be working. So, and this is a copy of pretty much of what you find on the expressive side, but what it has on board, this is a pinout diagram which we'll look at later in a minute, but what it has on board is one of these expressive S3 W room, or however you want to say it, -1 units like this one here. And in any case, to make a long story short, there is sort of a table over here, and what we have is this one over here, a ESP32-S3 room 1 N16R8, which seems to be indicating that it has 16 megabytes of flash, which is actually double than what the OTG board is that I got from Expressives, and it also has 8 megabytes of SPI RAM. And here is the official Expressive DevKit diagram there, and it has the schematic or circuit diagram, but it is a little different from the in concept it is the same, but there are some differences, and that is as follows. In fact, I think the Chinese clone has a few extra features there that are useful. This is the schematic of the Chinese clone, and you'll find that that part of it is the same, but it has a couple of little jumpers on there, like solder jumpers. Now this one, it says it is version 1.4 schematic, and the board I've got actually says it's version 1.3, so it is possible that there are some minor differences. And one thing that I can say is I do not know exactly what this is all about. It's got like a 0.603 resistor or something, but the one that we have, there's just some little pads there, solder jumper that you can jumper across, presumably this diode. And of course what happens is, and it's marked USB OTG, so if you want to use this socket as an input from, let's say, a keyboard or some device or a mouse or something, you need to supply power to it. So that is probably what that's all about. You jumper that and then it will provide power out. And remember, in some of the episodes that I have done for the Adventure series, the ESP32 USB OTG board actually has a built-in switch that you can actually access via GPO18 to turn on and off to do a similar feature to get the power out. And then there is another jumper over here which actually allows you to select whether your 5 volts is going to be coming from the USB connector. There's 2 USB connectors on there. There's one marked UART and one is marked COM. And if you have plugged in the other USB cable, obviously it's getting power from there. But if you want to run this module just by itself off some power, then you will have to. This is another solder jumper that is there. You have to short that out. And that's about all that I could see that was of any significance that would be slightly different from the official version. The rest appears to be similar, if not the same. Yeah, so if you look at the pinouts, this is the Chinese clone. The buttons are in a different place, of course, and there's no differences at all in the pinout. It's exactly the same. And reason being, of course, is that those pins over here are connected directly to the ESP32 room module. So to get this working with PlatformIO, I created a board file for it. I based it on the DevKitC-1, obviously, because it is very similar, but there are some differences which I have. It's got twice the amount of RAM than the standard one, and as you saw on that page over there, you can actually buy the 8 megabyte version as well, which will be completely compatible, and it's only like 50 cents cheaper or something. So I decided to get the 16 megabyte one, so I set partitions to default 16 megabytes. Looked good to me. I had a look at that CSV file. It just tells you which portions of the RAM it uses for what, and the offsets are just a little larger, so it can use more RAM. So I believe that will work. If I run into problems, I can always turn it back to 8 megabytes. And another thing is that it has PS RAM, 8 megabytes. So I put this switch in here, define Arduino has PS RAM. I couldn't find any place anywhere where you actually specify how much PS RAM it has. I guess the ESP32 itself will report how much it has, I guess, and so we don't need to specify that. The rest stays the same. It's still 80 megahertz flash speed and 240 megahertz CPU, and it is ESP32-S3, and the rest I did not change, except I changed the name. On the back of the board it says YD -32-S3 room. Well, it has 1.3, so I decided to add the W room one, and this is on the actual ESP chip, so I added to that. And that's all I've done. And then in PlatformIO, I put the board name in there that I created, and then I actually downloaded a RGB sample file. I actually got that from a sample file from Arduino. I made a few changes to it just to play with it and experiment. If you use this code over here, it actually turns on it turns it on as a white LED, and if you turn it off, it turns it off altogether. So that's one option how you can use. It's got like a NeoPixel RGB LED on there, but you can control its color, and originally it just had blue, red and green, but I decided to play with it and make it blue, green, cyan, red, magenta and white, and I found that our eyes are not very sensitive to blue light, so I created a couple of values that over here you actually put the values in there when NeoPixel writes, so you can actually put like 32 or 64 up to 255. It says up the top there. It was originally set 64, so I reduced the I created an on value for 32 and an on extra value is 64 and off is 0. So you pass that to the little lights, and if you have a look at it, okay, so here you can see it running. It's hard to tell the different colors. If I put a piece of paper over it and turn off the lights, you might, well, that doesn't help. Shield what you see, you can see the different lights: white, blue, green, cyan, red, magenta, and white again. It's clear to my eyes, but these cameras, they get overloaded very quickly. Everything looks white. Anyway, so that's working. So we've got another little board to play with. Now you're probably wondering what these little switches are all about, so let's have a look at the little board itself. That's those jumpers that were there. Alright, so this is the board here. That little module here tells you N16R8. So that's 16 megabytes and 8 megabytes of SD RAM. Two little buttons, reset and boot. 3 LEDs. One is like running and one is loading and transmit and receive. Transmit and receive and running. This is the little NeoPixel LED, and this is the little jumper over here that you have to put some solder on before this thing will work. I've seen lots of people complaining NeoPixel doesn't work, and they probably didn't look at the board and realize that it's turned off by default. Maybe because they want the pin 38 or whatever it is. If you want to use it for some other purpose, then you can choose to do so and disconnect that NeoPixel. There is also a little jumper over here that's the one that's marked in and out, and on the other board, of course, as I showed you, I put some soldered wires on there, and it's got a little switch hanging off it that so I can play with it. That is just for power. It either gets power to the USB port, or it can get power through that 5-volt in pin, and that thing is directly connected to here. And if you put a blob of solder on there, it gets directly connected to this 3.3 volt voltage regulator. Then on the other side, there is another little solder pad here, USB OTG. That's where they direct the power out of the USB port here. So the COM1 on the real board that's marked UART. The COM one is what you plug into the PC for programming and serial monitor and what have you. And the one marked USB, that's the second one, is actually the port that you can use as either as an input or output OTG. So if you are emulating like a device, then you wouldn't want the OTG thing to be connected, and you can connect this to a PC and it can emulate a keyboard or a mouse or some other device, whatever you've got hooked up to here. And like you could potentially hook a joystick up to this thing and then output this to the PC and make it act on the output. Or you can wire that OTG thing and then you would be able to use this thing as an input for a keyboard or a mouse or something to the USB port. The only other thing of note is that this port here is indeed the one that's connected to the so-called, it says COM, acts as a UART, so it's a little chip over here that actually takes, as you can see, it leads directly there. And it takes the USB input and converts it to receive and transmit, to the UART, and that's why there's two little LEDs here that will light up depending on the receiver transmit is on. And that is all that there is to say about this thing, and I think it's working. So I thought for $10 that's a good price for this little board, on account that I paid $35 for the OTG one. Now obviously the OTG one is a heck of a lot more sophisticated, and it's got a display on it and all that sort of stuff. And the only other thing that to mention is that these boards have got a form factor as such that when you try to plug it into a little breadboard, you can't access all the pins very easily. So as you can see, when you plug this thing into one of these little breadboards, there's no room on the other side, and there's only one row of pins available on this side. So what you might want to do is, this is what I did, is these ultra cheap little breadboards from China, I seem to have got a whole bunch of them that were included with things. You can reconfigure those, like they can come apart, and you can put them back together again. And so I had two of them here, and that's what I've done. And I've actually reconfigured this. I've got two of them, and I put a row of these power pin things over in the middle here. So now I can actually plug it in, and I've got two rows of pins on each side now. And I also have this, I've had this one for a while. This one's even wider, and it also can go on here. In the past, I have actually made adapter boards for them like this. Plugs in to a strip of DuPont pins, and then on the bottom I just connect it together, and then I can, and also made a little power supply thing for it. You can get power coming in, but for experimenting this is actually easier. I can just put it on there and we'll be in business. And this one here, as I said, I actually soldered on wires on those little solder pads with little switches, so I can actually switch it on and off for experimentation. And this is the OTG one at the bottom. I put some hot glue on there so that the wires, don't can't get pulled off on that one. Again, I can switch it on, I can switch it off. So that's what we'll be using also for some of the episodes in the series that I'm doing on the ESP32 Adventures. This was just a little sidetrack here. I wanted to get another S3 board to test some of our stuff out when we get to do more things with screens and stuff like that. Anyway, that's all I've got for this little video. So I'll see you guys later.